In this video, we'll take up the homework for special angles. For the first question, we have a ladder that's 15 meters long and it's leaning against a building. Luckily, the angle that the ladder makes with the ground is 60 degrees, which is a special angle. So we can find the exact values for our answer. And we're going to do that by using the sine ratio because opposite over hypotenuse. For second question, you have the same 60-degree angle, but instead of using a sine ratio, you're using the tan ratio because opposite over adjacent, and you can solve for the height. For question 3, you're changing the angle from 45 degrees to 60 degrees. So by calculating the change in height, you can calculate the vertical displacement. And for 3b, they're asking you to do something rather silly, which is find the value to the nearest tenth of a meter. Nothing is better than exact values, so on the test, we certainly won't expect you to do this, especially if you don't have a calculator. For question 4, you have a right isosceles triangle. We use a sine ratio to calculate the distance. And in part B, another way of doing it is to calculate, actually there should be, so b squared. So another way to calculate distance is using the Pythagorean theorem instead. For question 5, so Alicia and Janita are holding a hot air balloon using guide ropes. So Alicia holds a 15-meter rope but makes a 30-degree angle, whereas Janita has a 45-degree angle to the ground. So they're asking for the height of the balloon. So solve for BD, 30 degrees here, and use the sine ratio to solve for BD, which will give you 15 over 2 meters. And then they ask how long is Janita's rope. So please don't assume it's 15 meters. So Janita's rope is BC, so you can use the sine ratio again because BD is opposite and BC is hypotenuse. You get exact values because you're working with a special angle of 45 degrees. And lastly, they're asking how far apart is Janita and Alicia. So that, based on the diagram, is AD plus DC. But if you look closely at the diagram, DC, the length of DC is the same as BD because triangle BDC is a right isosceles triangle. So I don't have to do much math to solve for DC because I already know what BD is from part A. Now AD, I need to do some math. I'm going to use a cosine ratio to solve for BD because I have the length of the hypotenuse and I'm looking for the length of the adjacent side. Nonetheless, you solve for AD and then you can add it to the value of BD, and that will tell you how far Alicia and Janita are apart. And that's the solutions for the special angles homework sheet.